Hello friends, welcome back. In the previous tutorial, we have created vector 3D structure which is similar to vector 3 structure in Unity, and we also created vector 2 structure which is similar to vector 2 structure in Unity engine. And we have understood in the previous tutorial that what are the operations that we can perform on vector 3, how it is different from vector 2. I also explained that we use two pipelines before the vector and two pipelines after the vector to indicate that its magnitude, whereas we use single pipeline to indicate the absolute, right? Before and after, if we use single pipeline to indicate its absolute value. Then, as I told that we can perform addition, negation, subtraction, scalar, multiplication, find magnitude, get the normalized vector, find the dot product on vector 2D as well as vector 3D, or vector 3 as well as vector 2, whereas 2D and 3D vectors you can say. Whereas we don't have a cross product in vector 2 structure. The reason is that we have here, we have a x-axis, we have a y-axis, we have z-axis. If we are working in 2D, we are locked to x and y axis. We can rotate only around z-axis, but we cannot rotate around x and y axis. We cannot rotate around x-axis, or we cannot rotate around y-axis in the 2D. That is the reason there is no cross function or a cross product available in vector 2 structure in the Unity. You can see that in the documentation also there is no cross function. You can see there is no cross function. Whereas when you come to vector 3 structure, you can find there is a function with the name cross, which takes the cross product of two vectors, which gives us cross product of two vectors, which is not available in vector 2 structure. Let us come back. Now we have understood that dot product helps us to find out the angle between two vectors. You can see the formula for that. You can use either this formula or you can use this formula. Here it indicates that the dot product between A and B vector is equal to the magnitude of A multiplied by magnitude of B times cos of the angle between the two vectors, that is theta. Now dot product, let us see here in the documentation and get some information. Dot product of two vectors, let me click on this. Here you can read the information. It returns a float value, single value, that is going to be angle. Dot product of two vectors. The dot product is a float value equal to the magnitude of the two vectors multiplied together and then multiplied by the cosine of the angle between them. That is the reason we have here cosine of the angle between them. Then for normalized vectors, dot returns 1. We have seen that in the previous tutorial when we were learning dot product. If they point exactly in the same direction, it returns 1, minus 1 if they point completely opposite, 0 if the vectors are perpendicular. And we have seen how it is useful to find out the angle between two vectors, whether the object is moving up or down or parallel. We have, and you can see some simple example. How do you use the dot product? The other transfer is behind me. That means if you want to find out whether one object is behind another object, also we can use the dot product. Here we have the code. Do you want whether this object is behind another object? The code you can see here. You can use this one in your game. Nice. They have already given a small example for how do you find out one object behind another object. We also use this one to find out whether the player is in front of the enemy or behind the enemy in the previous tutorial. Let us proceed and get some information about the cross product. Now what is cross product? Let us click on this and understand. Let's click this. Now here cross product, you can see it takes two vectors, left hand side and right hand side. It returns another vector. Cross product of two vectors. The cross product of two vectors results in a third vector. It gives you another vector which is going to be perpendicular to the two inputs vectors, which is going to be perpendicular to the two input vectors. That means let's take you have a vector A and you have a vector b. Let's take a is a right vector and b is a up vector. If you take the cross product of a and b, you are going to get a resultant vector which is going to be exactly perpendicular at 90 degree, or you can say perpendicular to a and b. That is the meaning of this line. The resultant vector's magnitude is equal to the magnitudes of the two inputs multiplied together and then multiplied by the sine of the angle between the inputs. First you are going to find out, you can say the dot product, you can find out the dot product between these two vectors and multiply, you get the float, and the sine of the angle you get that, and if you multiply to the normal vector, I will tell you what is normal. You can determine the direction of the resultant vector by using the left hand rule. That means if thumb is pointing to a vector and this the pointing finger is b vector, if you think, then the middle finger that indicates the resultant vector. And you can see the example code how it is useful. Let's come back to here pane. It returns the normal vector to the two vectors a and b. We have to understand this. Now here we are going to understand what is normal vector. We have learned what is normalized vector. What is normalized vector, guys? If you have a vector, its unit vector is a normalized vector. I hope you remember the magnitude will be 1, direction will be same, right? If a is a vector, then we write its normal vector as a cap. That is the normalized vector, a cap. Now what is normal vector? If you have a vector a, let us take, if you take another vector b which is exactly perpendicular to a, then b is normal to a. It is normal vector's friend. That means normal vector is perpendicular vector or exactly at 90 degree to another vector. Now when you take the cross product of two vectors, let's take you have here the right vector x, let's take you have the right vector x, let's take we have z vector, and if we take the cross product between them, we are going to get the resultant vector which is going to be exactly 90 degree, which is going to be the up vector, right friends? Here you can see that if it is a vector, if this is a vector and if this is a b vector, if we take the cross product between them, we are going to get the resultant vector c, which is going to be exactly 90 degree to these two vectors. That is the meaning of that. Now let's take here the b vector has the value x1, y0 and z0. Let us take, it's the right vector, unit vector also you can say. Here the a vector is going to be 0, 0, 1, which indicates the forward vector, you can say. If I take the cross product, I must and should get another vector which should have the x value 0, y value 1 and z value 0. Now if you want to find out the cross product between these two vectors, then either you can use this formula, magnitude of a times magnitude of b times sine of the theta, the angle between them, then we have to multiply with the a normal vector. But here you can see that we need to find out the theta and then we need to calculate this one. Instead of this, we can use the simple formula here, ay multiplied by bz. Let me copy this, ay multiplied by bz minus az multiplied by by, comma az multiplied by bx minus ax multiplied by bz, comma ax multiplied by by minus ay multiplied by bx. Let me copy this from here to this place and paste it here. Now this time what I do means, how do you find out the cross product between a and b? If you want to find out the cross product between a cross b, now what you need to do means, you need to write in brackets, because we are going to get the resultant vector. First you need to write a vector, then you need to write b vector, a and b. So a vector values are 0, 0, 1 and b vector values are 1, 0, 0. Now we have here ax and bx the column, then ay by column, az bz column. Now we have arranged properly. Now how do we find out the A cross B? What you need to do means, according to the formula, first we need to ignore this part. We are going to ignore this column. We need to ignore the x column. Then we need to take the cross product between these two. Now how do we take? Ay multiplied by bz. Ay is 0 multiplied by bz is 0. We are going to get 0 minus az multiplied by by. Az is 1, by is 0. 1 multiplied by 0 is 0, comma. Then in the next step what we need to do means, we are going to ignore the y column. To calculate the next value or to calculate the y value of the resultant vector, we need to ignore the y column, friends. And then we are going to calculate the cross product here. Az multiplied by bx. Az, comma, az is 1 multiplied by bx is 1. 1 multiplied by 1 is 1 minus ax multiplied by bz. Ax is 0, bz is 0. We are going to get 0 here, comma. Ax, now in the next step, if we want to calculate the z value of the resultant vector, we need to ignore the z column, friends. Remember these steps which help you a lot later. Then as I told that we are going to ignore z column and we find out the cross product between them. Ax into by. Ax is 0, by is 0. So we get the result 0 minus ay is 0 and bx is 1. We are going to get 0. Then we get 0 minus 0 is 0. 1 minus 0 is 1, comma 0 minus 0 is 0. That's bracket close. This is going to be our resultant vector C010, and you can see that we got 010, which is perpendicular to A and B. This is how we are going to perform A cross B. And always remember that the inputs that you give to cross function, you have to check whether you want to find out the cross product from A to B or B to A. And I suggest you people to check out, if you write B on top, A down, what result you get, what output you get. That is really useful if you understand. I hope you guys have understood how do we perform the cross product. This is how we perform. Let's write a code for that. Here we are going to write a code for that. Let's create a vector 3D. A vector is equal to new vector 3D, and A vector has the value 0f, 0f, 1f, bracket close. Another vector 3D I create, B, which is equal to new vector 3D, 1f, 0f, 0f, semicolon. Then I create vector 3D, C is equal to new vector 3D, which is going to be nothing at present. Then we say C is equal to vector 3D dot, we are going to use the cross function. Now to the cross function we are going to pass A left hand side, B right hand side. If we run the code, you are going to see the result debug.log, the C.x plus double quotation comma double quotation plus C.y plus double quotation comma double quotation plus C.z bracket close semicolon. Now here you should see what is the cross product. If I go to vector 3D structure, I have pasted already the cross function, which is performing the same operation that we have done. This code, what you see, is exactly equivalent to the code that we have understood. What happened? Let me copy this, come back to the paint here and paste it. Yeah, here we have that code, and you can see here, if I replace all LHS with A, LHS A here I replace A, here I replace A, here I replace A, here I replace with B, here I replace with B, here I replace with B, here I replace RHS by B, RHS by B, RHS by B. If you compare these two, they are exactly same. AY multiplied by BZ, AY multiplied by BZ minus AZ multiplied by BY, AZ multiplied by BY, comma, AZ multiplied by BX, AZ multiplied by BX minus AX multiplied by BZ, AX multiplied by BZ, comma, AX multiplied by BY minus AY multiplied by BX. So both are same. Now if I run the code, I should get C is equal to 0, 1, 0. Let's come back to Unity and run and check. You can see that we got 0, 1, 0, which is exactly perpendicular to the A and B vectors, friends. This is how you can use the cross product. Now how it is useful in the games or simulations? Let's take an example for that. Let's take here enemy is standing and it is looking towards this direction. That means it is looking in Z direction. The enemy is looking in this direction. And let's take the player is over here, player is in this place. Now what we want to rotate the enemy to see towards player and start shooting, let's take. Then we need to find out whether the enemy need to rotate around y-axis or whether the enemy need to rotate around x-axis or the enemy need to rotate around z-axis. At present, we know that the enemy need to rotate around y-axis. It should rotate like this. It should rotate like this, right? It should rotate like this and see in this direction. What we need to do means, first step, we need to take a vector from enemy to the player. We know how to take it. There is no problem in that. Then we already know the enemy's forward vector. Already we know the enemy's forward vector. Then we need to take a cross product between the enemy's forward vector and the direction vector. Once you take the cross product, you are going to get the resultant vector, which is going to be exactly perpendicular to the forward vector and the direction vector. Then you need to rotate the enemy around this axis so that the enemy starts seeing in this direction. Then you can check out if the distance between the player and the enemy is less than 100, whether it is in the viewing distance. If it is there, then you can start shooting or maybe enemy starts chasing the player. This is one of the good example for how we use the cross product in the games or simulations. Then I hope you guys have understood. Please try to understand each and every point. Then let us proceed and get some more information. Let me come back. Here we have another important method I would like to discuss, that is project or project on plane. Projects a vector onto another vector, which is also one of the useful method. Let us understand this. Here we have a project vector method which takes two vectors. One is the vector, another one is the normal vector, normalized vector, not normal I can say, normalized vector I'll say. Now projects a vector onto another vector. It projects a vector onto another vector. To understand vector projection, imagine that on normal, let us take this is on normal, one unit vector is resitting on the line, pointing in its direction. Let us take this is a line and this normal vector is sitting on this line and pointing in the same direction. Somewhere along that line will be a nearest point to the tip of the vector. Let us take somewhere on this line, at the tip of this vector we have a point. The projection is just on normal. The projection is just, is a normal rescaled so that it reaches to that point. It reaches to that point. Let me explain that here graphically. Let's take you have a vector, let's take you have a line and here you have a point and this is a normalized of that point. From here to here you have a vector and this is a normalized, you can think like that. You have another vector something like this and you want to know the shadow vector. the shadow vector from here to here. You want to know what is the length of this shadow, and you want to know what is that vector which is falling here. Let's take, you have the torch or a light in this direction, then we know that the shadow is going to fall exactly on this vector pointing in this direction. Now this one is actually known as projection. Projection of this vector, let us take this one is B and this one is A. Projection of B on A we can calculate very easily, and how it is useful also you can read here. An example of use of projection is a rail mounted gun that should slide so that it gets close as possible to the target object. The projection of the target heading along the direction of the rail can be used to move the gun by applying the force to rigid body. Say, here they have given an example for that. I suggest you people to understand this, read and get some idea how the projection vector is useful. Now we have covered most of the vector operations. 2D and 3D. We got a lot of information, my friends. You people need to understand, analyze, practice these things and get more examples and applications of these online. I suggest and I request. Now what we are going to do in the future tutorials, we are not going to use our vector 2D and our vector 3D structure. We are going to use Unity's vector 2 and vector 3 structures to perform lot of operations, or in games as well as simulations that we create. Definitely we are going to use Unity's vector 2 and vector 3 structure, not our vector 2D and vector 3D. We just created them so that understand how actually the code is working in the Unity engine's vector 2 and vector 3 structures. I hope you guys have enjoyed and learned all of the topics that I have explained. And here we have a K epsilon. I think you might be having the question, what is this K epsilon? K epsilon is a small number, friends. Let me show here. Here I write debug.log mathf.power of 10 comma minus 05f bracket close semicolon. Let's save this. Let me save this and come back to Unity and run and show you. If I run the code, you can see that we got 1e-05, 1e minus 05. That is the scientific notation of 10 raised to the power of minus 05f, which is actually equal to 10 1e minus 05f, which is actually equal to 10 raised to the power of minus 05f. I hope you know about floating point values representation, scientific notations and floating point representation. If you don't know, please go online and understand, which is a very small number. This we use in vector 2D. I think we have used somewhere to check whether the magnitude of a vector is smaller, nearer to 0, right? 1e minus 05f is very small number. Then if magnitude is greater than that, then we divide, otherwise we return vector 2D 0. That is the reason they have one constant in vector 2D and vector 3D, which is known as K epsilon. We can say here also we can put ourself. Now I hope you understood what is that. What is that constant value? K epsilon. Let's save it. I can use this K epsilon. In this place. Instead of writing this number, I can write the K epsilon. Most of the things I have tried to cover about vectors in these tutorials. I hope you guys have enjoyed and learned a lot, and I also suggest you to learn more and more, practice more and more. In this tutorial we have understood what is normalized vector, what is normal vector, how cross product is used, what is the projection vector, and so many things. Let's go back here, and I suggest you people to go through these things understand what exactly present inside the Unity Engine's vector 2 and vector 3 structure, other functions, what code is present inside them, how the codes are calculated, debug, create your vectors, analyze, graphically draw and understand how those other functions work. There are many other functions, like we have min function, max function, we have move towards function, many other functions like clamp, magnitude function. Check out, and they are simple, they are not much difficult to understand. You just need to go and check the code. Hope you guys have enjoyed and learned so much. Thank you guys, thank you very much. See you in the next tutorial. Keep learning, keep coding, keep sharing.